Okay, Assalamualaikum warahmatullahi wabarakatuh. So let's move to the last analysis for your DC. So in your previous video, you learned about the DC analysis for mathematical approach. So we have three model. The first one what we call ideal model. Second one is PLM1, and the third one is PLM2. So the aim of these three model, we want to find ID and VD. So that is what we call assumption model. So there is another type of analysis where we call graphical approach. So this is from the graph of the IV characteristic of the diode, where we need to find again ID and VD. So why we call this one graphical? Because it is based on the graph. Okay, so do you still remember the IV characteristic of the diode? So I've explained in the previous chapter. So we have what we call ID and VD. So it will be divided into two parts. The first one is reverse bias. The second one is forward bias. And in between the reverse and forward, where we call here VBI or V gamma. So what is this V gamma? Is the turn on voltage of the diode. So if the supply voltage is less than your V gamma, you will be reverse bias, means there will be no current. If it is more than V gamma, it will be forward bias, and then will be a current. So in this graphical approach, we will base on this IV characteristic of the diode. Okay, so from this IV characteristic, so this approach where we need to have what we call this keyword load line. So if we go through here, so this is what we call load line. So what is load line? Is where you are going to have a line at the IV characteristic. So for example, this is the line. So you need to find the point of this coordinate and this point of this coordinate. And then you're going to have this straight line. So this green line is called load line. So what is the function of this load line? Is the intersection between this load line and the blue one here is IV, right? So the intersection between this load line and IV is the point that we want. It means here is will be ID and VD. So always remember the gain of this DC analysis, we want to find ID and VD. So since this is a graphical approach, so we need to find this load line. So how are we going to find this load line? How? So we need to find point A, and we also need to find point B. So this is X1, Y1, for example, X2 and Y2. So how you can get this coordinate point is this graph of IV is from a circuit, right? So let's say the circuit here is a supply, a resistor, and the diode. Okay, so if you have a KVL equation here, so let's say this is VPS, this is R, and this is VD. The current across the diode is ID. So KVL says minus VPS plus RID plus VD equal to 0. So in order for you to find this coordinate, you need to have this equation of the KVL. So what is the role of this equation? Okay, look back at the IV characteristic. So for your IV characteristic here, your Y, will be your Y, this will be your X, right? So means you need to rearrange this equation become a line equation, because the green load line here is a line equation where we call here Y equal mx plus c. So you need to rearrange this equation, the KVL here, this is the KVL, into Y equal mx plus c. What is the Y here? Y here is ID. Slope you don't know yet. M is equal to VD plus the intercept. So use this KVL equation and rearrange it, so it will become ID equal minus VD over R plus VPS over R. So how you can get this equation? From this KVL equation, you need to rearrange again. So here will be Y, here will be X, the whole here will be your interception. What is your M here? The slope here is equal minus 1 over R. Your C will be VPS over R. Okay, once you can get your line equation, so this line equation what we call load line equation. So how you can find point A? So it's intersect, right? Means that point A is actually x equal to 0. Point B means y equal to 0. So what is x here? X here is actually VD equals 0. ID will be equal. So if let's say we make this VD equal to 0, your ID will be equal VPS over R. When y equal to 0, y means what? Y means ID here. So when ID equal to 0, your VD will become VPS. So you can denote here where means at your A point here is actually, this point here is actually VPS over R. So at your B point here is actually VPS. So when you have these two coordinate A and B, you can draw this line. So this line what we call load line. So why we need this line? Because the intersection between the load line and the IV characteristic is, this is the final point that we want. The ID and VD based on the graphical approach. So these are the three keywords when you have the load line. So you need to have a linear equation. Y equal mx plus c. How can you get this equation? Find the KVL from the circuit and you denote y is equal to ID and x equal to VD. Okay, so these are the summary of the step that I explained just now. First, you need to get the KVL equation. So what is the KVL equation here? Is from your circuit. So KVL. And then you need to rearrange the equation between, become a line, y equal mx. What is your y here? Y here is ID. So this is wrong, ID. And x here is VD. X here is V. This is x. This is y. So how you can get the intersection of the load line, this point of A and this point of B, is from the, when you equate this one, what happened when y equal to 0, what happened when x equal to 0. So that's how you can get the load line. So why we need this load line? Because the intersection between this line and the IV characteristic here, this is what we call Q point. The Q point. What is the Q point here? Is actually your VDID, the final answer that we would like to have. Okay. Okay, so this is one of the example from the previous midterm question. So when you say graphical approach, so the question will give a graph of IV, and maybe it will be have a load line here. So in the end, also it will give a circuit. Okay. So the question say here design. So you know from the previous chapter, design means what? You need to find the unknown value. Unknown value. So in this case, what is the unknown value here? Is the R value. Okay. And also you need to determine the diode current and the diode forward resistance and then V gamma. So please try to solve this question by yourself. We will discuss this in the class inshallah. Okay. So please take note here. When we have V gamma and RF, so this will be piecewise linear model 1 or model 2. So this will be piecewise linear model 2, where you're going to replace your diode with V gamma and RF. Okay, so during forward bias. So here you already been given the value of intersection 2 and 5. Come up with 1 KVL equation. Number 2, the load line equation. Number 3, the intersection of point A and point B. Point A and point B. So once you got the intersection, move to the question number 2, where you're going to replace your diode with V gamma and RF. Okay, so we will discuss this question in detail in the next unit session. So that will be the end of this part. Assalamualaikum warahmatullahi wabarakatuh.